Okay, so here we have the next question on the menu today, where we have the following situation. A uniform bar that has a weight force of 165 newtons is supported horizontally by two identical wires A and B, as they are shown in the figure. Cool. And we have a small cube that is 185 newtons that is 3/4 away from the distance between A and B. So closer to B. As you can see from the diagram, the wires are 75 centimeters long, have a mass of 5.5 grams, and both of them are simultaneously plucked at the center. So we're trying to figure out what is the frequency of the sound that will be produced from them. It's kind of like a guitar. I got a guitar right there. Guitars are my favorite instrument. Pretty cool. So let's actually draw a diagram of this, and then we can put on the forces, and with that we could get the answers that we need, because the fundamental concept that we need here is oscillation. Oops, let's get a black pen. Oscillations in strings under tension. Okay, the equation that we're looking for in this situation is this equation. Okay, so the frequency is the tension over mass times the length of it. All of this is under the root, and that whole root is divided by 2L. Okay, so this is the equation that we need to use, and the only thing that we're missing is T, because everything else was given in the question. Okay, so when we think about, let's just identify what we had from the question. Our mass is the mass of the string or the wire, so it's 5.05 grams. It's 5.50 grams, and that is equal to 0.0055 kilograms. All right, it's better to work in kilograms. Base SI, that's the way to go. Our length of those wires are 75 centimeters, also known as 0.75 meters. And yeah, now we just need the tension. Okay, so let's draw a free body diagram of this situation. Okay, so here we have tension A, our left side. Here we have our right side, and let's call that tension B. In the exact precise middle of here, we have a downwards force of, let's just call that weight, WB, for weight of the bar, and then 3/4 of the distance. Closer to the B side, we have the weight from the cube. So let's say WC for weight of the cube. Okay, let's say this distance is L, so this would be 2L, and the whole thing would be 4L. Okay, so to find the tension here, what we're going to need to do is, we know that the force from the bar itself is 165 newtons. And the weight from the cube, that is 185. Now, one thing that we need to do is we have to find the amount of tension in each one of the cables individually. We don't really have a way that we can do this without using something called moments. And we know that this bar is not going to be moving, right? If you're plucking it, like if I pluck a guitar string, it's not going to move the entire structure of the guitar. Similar type of thing here. So the plucking is not going to actually cause any motion. We're going to assume that we are in static conditions right here. Okay, so to find the moment, let's first take the moment about point A. So here can be point A, here can be point B. So moment at point A. Let's say counterclockwise is going to be positive. The sum of all moments about point A has got to be 0. And we're going to pretty much just see here where we're going to, have these, who's going to cause us to try to rotate. That's what the moment is like our tendency to rotate. So our WB is going to try to make us rotate in the clockwise direction. That's negative. So it's going to be negative WB. And we need to multiply it by the distance that it is away from the point at which we're rotating about, or hypothetically rotating about, and that's A. So in this case, it's 2L. Okay, and the next term is our WC, and that's going to be 3Ls away. And also going to be negative because it's going in the clockwise direction. So negative WC and 3L. Okay, and the last one is going in the positive direction, and it's got to balance out both of these. We have the tension B, and that's going to be 4Ls away. So plus tension of B, and multiply that by 4L. 4L, that's for life. Okay, so we can isolate these, and we can solve for TB. As you can, let's first move the W terms to the left side of the equation. So we have positive WB 2L plus 2WCL is equal to TB 4TBL. And as you can see, we can just divide both sides by L, so everyone can lose their L. We don't take no L's around here. Ahahaha. Like that. And then we can quickly erase the L's, and this will be perfectly mathematically valid. We still need that 2. And that W. But we can also divide both sides by 4 to just get TB. And we know that that's just going to be like 1/2. Whoa, it's 3WC. So it's actually not going to be 1/2. We're not going to be able to factor that out. My bad. So instead, we're going to have 1/2 WB plus 3/4 WC. Okay, and then we just got to sub in these numbers. So WB, our bar, was 165 newtons. Plus 3/4 of WC is 185 newtons. This is our tension in chord B. Okay, so let's do this calculation real fast. Times 165 over 2 plus 0.75, the same as 3/4, times times 185. Cool. So in this case, our tension in chord B is going to be equal to 221.25 newtons. That's our tension in B. Okay, now we need to find our tension in A. We could do it another way with a moment, but another way that we can do this is we just take the sum of all forces, sum of all vertical forces. Okay, we can do that with a situation like this. Setting it up like this. So the sum of all vertical forces, with up being positive, we're going to have our two tension forces that are positive. So TA plus TB, and our two weight forces that are going down. And they have to be perfectly equal to each other when they get summed up. Otherwise, this would be moving, and this is not moving. So, yeah, so that's going to be minus weight of the bar minus weight of the cube, and that is all equal to 0. Okay, so we can see that the tension forces balance out to be perfectly equal to the weight forces. And they're both going to be positive once we bring them to the other side. So we just calculated TB. So to solve for TA, this is going to be the weight of the bar, so that's 165 newtons minus plus 185 newtons, not 18, minus 221.25 newtons. And TA, I expect that to be less than TB because it is, more of the weight is closer to TB. So TB should be under more tension. So let's add this up. 165 plus 185 minus 221.25. And my calculation for this is 128.75 newtons. Cool, so that is how we find the tensions, and once we get the tensions, we just need to substitute them into here. Okay, so F is, let me just copy this and bring this down so that it will be easier to deal with. Oops. Okay, technology is cool again. Let's sub in these numbers and see what we get. So let's first find the frequency of A. So let's, under the root, we got our tension of A is 128.75 newtons divided by mass, which is 0.0055 over 0.75, all over 2 times 0.75. Okay, let's calculate this out. Underneath the root, we got so we got 128.75 divided by 0.055, 0.75, and that whole thing divided by 2 times 7.75, so that's divided by 1.5 overall. And the frequency for this is going to be 88.33 hertz. Okay, not tremendously much. You'd be able to hear that. That's really, really low though. So maybe like a low bass guitar note, that would be like what it's like. But that I expect that the frequency for B is going to be higher because B is under higher tension, and as you know, if you play guitar, you know, when your tuners increase the tension in the chords, you get higher frequencies, higher pitches. So let's do that with the frequency for B. Okay, so the frequency of B was 221.25 over the same 0.0055 over 0.75. all over 2 times 0.75 to follow the equation protocol, and let's figure this out. Okay, so conveniently my calculator has some RAM, so it actually remembers the previous calculation. I can just sub out a different number. So my calculation for this, 115.80 hertz. Okay, so it's going to be a slightly higher frequency, but still very, very low. Like, you'd be able to hear this, but it's very low, you know? Okay, cool. So that would be the frequencies that they would produce. They're fundamental. Okay, awesome. So we don't really have a solution here, so missing solution. Missing solution. A is 88 hertz. B is 115 or 1.6 hertz.